So let's take a look at some examples using the laws of exponents. The first one here, we are raising a fraction to a negative exponent. So one way you can think of it is take everything on the outside, or rather to the inside, to the outside power. So I'm going to take the number -2. Notice I'm putting the negative inside parentheses because that's where it was originally, to the -3 power, and then the number 3 to the -3 power. And then we can go back to our, if I cross the line, it's going to toggle the sign of the exponent. So it's going to change it to its opposite. So if I move the -2 down, it's going to change the power to +3. And if I move the if I move the 3 to the -3 up across the line, again, it's going to toggle the exponent to its positive. And now I can go ahead and take 3 to the third, and -2 times itself 3 times is -8. That's the same way as thinking of this problem as what's -2 cubed and 3 cubed, and then at the end the negative in the exponent says take the reciprocal of that answer. So -2/3 times itself 3 times is -8/27, but the negative in the exponent says flip it, 27 over -8. Either way, you're going to come up with this fraction as your final answer. For the second problem, we have a term raised to the 2 power. And the only thing being raised to the 2 power, the base here, is this x to the -3 y to the 4th. The -5 will simply come on down. When you raise a power to a power, you multiply the powers together. So -3 times 2 and 4 times 2. Remember, to get rid of parentheses, we sort of think of it as distributive, but it's not really distributive. Next, I can imagine that there's a line here. Any negative exponent is going to cross the line. X to the -6, we're going to drop it down, and it becomes x to the +6. Now, I don't want to do it to y to the 8th, because if I cross the line with it, it's going to become y to the -8. I want the sign to stay positive, so all positive exponentials stay where they are. The -5, the exponent on it, or the power, is 1, and 1 is positive. So I keep that up at the top. The number can be negative, the exponent cannot. So this final answer is -5 y to the 8th over x to the 6th. In the third example, I can look at this as 3 separate little problems. The number part first, 12 divided by 4, is just the number 3. With these x's, I want to get rid of negative exponents. So again, cross the line, change the sign of the exponent. X to the -9, cross the line, change the sign. Y to the 2 is already positive where it stands, so I'm going to leave it. And y to the 7 is already positive, so I'm going to leave that. Since I have x's both top and bottom, that means I can cancel. And if I wanted to, I could write out 9 x's across the top and 3 x's across the bottom. If I cancel an x for an x, I'm left with 6 top side, so that's where the bigger number of x's are. And if I do the same with the y's, I have 2 y's on top, I have 7 of them written across the bottom, and I cancel a y for a y, all the y's on top will cancel, and I'll be left with 5 of them down below. But I need to have it in terms of positive exponents if I'm going to do that idea of canceling. I can't do it here because you can't talk about a deficit of 3 x's. You've got to have 3 x's and have 9 x's to do this canceling. This is your final answer. Okay, positive exponents only. So another example or two of these problems would be something like this, where you have fractions. So another fractional one raised to a power is this, x squared y cubed over x to the -5 y to the -3. And then raise that all to the 2 power. There's a couple of ways that you can work with this problem. I generally raise everything to the outside power first, get rid of the parentheses. You don't have to do that, but That's just the way I start them out. When I raise a power to a power, I multiply the powers together. And then once I get rid of that outside parenthesis, I can then do like we did in the previous question. Any negative exponent needs to cross the line. Any positive exponent is going to stay put. So x to the 4th is positive. I'm not moving it, but x to the minus 10 is moving up and becoming x to the positive 10. This y to the 6th on top is positive, but this guy is negative down below. I'm going to move it up top side. Once everything's moved up, it's really over 1, so I don't need to worry about that. And now I can count up the number of x's. I have 4 on top, and then I have 10 more. All total, I have 14. And the same with the y's. Multiply like bases, add up the exponents, or simply count. I have 6 y's, and then I have 6 more y's. That gives me a total of 12 y's. As another example, and like I said, some of these will get a little more complicated the more variables you have in the problem. Negative exponents can be a little more complicated. We'll kind of throw them all together here and then raise this to the negative 2 power. Right, so for this one again, I'm going to take everything inside and raise it to the negative 2 power. This negative is inside parentheses, so I'm going to keep it in parentheses when I raise the number to the negative 2 power. X to the 0 to the negative 2. Again, when you raise a power to a power, you multiply. 0 times anything is 0. Y to the 6th. And on the bottom, z to the negative 10. Get rid of negative exponents by crossing the line. And again, the only sign that changes is the little power exponent sign. X to the 0 is 1, so I can go ahead and substitute that out. Y to the 6 is positive. Z to the negative 10 crosses the line, toggles the sign to the positive of it, changes it to its positive, and then simplify. So I end up with a negative 3 times negative 3 is positive 9 on the bottom. I don't have to write the 1 in. I can if I want. You don't have to, though. And then this would be your final answer. As my last example, I have this one, negative x to the 5th, y squared cubed, times negative 3 x5 y6 to the negative 2. Okay, and again, you can think of this as negative 1, and I'm going to raise everything to get rid of that outside power, get rid of the parentheses. So this is negative 1 to the 3rd, x to the, multiply them out, 5 times 3, 2 times 3, and again negative 3 to the negative 2, x to the negative 10, y to the negative 12. Everybody right now is above a line. Any negative exponent now is going to drop, so these 3 are all going to drop down and become positive exponents. Negative stays on the 3 though, the power changes its sign. Alright, negative 1 to the 3rd, that's negative 1 times negative 1 times negative 1 is still negative, and all of these have positive exponents. Okay, so negative 3 squared is 9. I still have a negative up top, or a negative 1 if I want to write the 1 in. I have 15 x's on top, but I have 10 x's on the bottom. So I can cancel, and if I cancel an x for an x out, I'm left with 5 of them top side. On the y's, I have 6 across the top, but I have 12 of them across the bottom. So if I cancel a y for a y out, I'm left with 6 of them on the bottom side. You should now be able to complete the assignment in P2, so go ahead and try those problems for your homework.